All right, let's dive into the world of efficient language models. We're looking at OLMoE today.
Okay.
It's a model with a ton of parameters, like 7 billion.
Wow.
But get this, it only uses a fraction of them at once,
Interesting.
like a Swiss Army knife for AI.
Yeah, that makes sense. It's built using this thing called mixture of experts, MoE.
MoE.
Yeah, MoE. It helps make the model super efficient.
So instead of one general AI, we've got a whole team of specialists.
You got it. Each one jumps in when needed.
I like it. So what makes OLMoE different from other MoE models,
Well, it's fully open source.
you mean?
Everything, the weights, the data, the code, even the training logs.
Wow,
It's all out there for anyone to see and use.
that's amazing. So anyone can basically tinker with it.
Absolutely. It's crucial for the research community.
I bet. Open source is a game changer for sure.
For sure.
But can a model that's focused on being efficient actually compete, performance-wise?
Oh, this is where things get really interesting.
Okay, tell me more.
So, OLMoE, even though it uses only about 1 billion parameters at a time, it's outperforming others.
Really?
Yeah, models with similar active parameters, even bigger ones like Llama2.
No way. It's beating those larger models.
You can see the results in the paper, table 4.
Hold on. So a smaller, more efficient model is beating out the big guys. How?
It's all about how MoE works.
Okay, break it down for me.
Think of it like doctors.
Doctors.
Yeah, instead of one general doctor, you have specialists.
Ah, got it.
You've got your heart specialist, your brain specialist, and so on.
Makes sense. So OLMoE is like an all-star team of AI specialists called in when needed.
Exactly.
That's so cool. But what are active parameters? You keep saying that.
Oh, right. So active parameters are the ones being used at a given time to process information. It's like how many brain cells are firing when you're thinking hard.
I see.
The fewer active parameters, the more efficient the model is.
So less energy and faster processing, right?
You got it. Lower costs, too.
Makes perfect sense. So OLMoE is doing more with
Exactly. Now, OLMoE has 64 experts per layer,
Okay.
but only 8 were active at a time.
So it's got options, lots of flexibility.
Exactly. It picks the right expert for the task.
I bet building this model wasn't easy. Were there any hiccups along the way?
Oh, definitely. They tried all sorts of things.
Like what?
Well, they thought using shared experts would be good.
Shared experts.
Yeah, ones that are always on no matter what.
I see.
But it actually backfired.
Really? Why?
It made the model less flexible.
Huh. That's counterintuitive.
Right. It's like having a doctor who insists on seeing every patient, even if it's not their specialty.
Yeah, that wouldn't work out too well.
Not at all. So having that dynamic, specialized team is key.
Each expert gets their moment to shine.
Precisely.
Okay.
And that brings us to another cool thing about OLMoE.
Okay, I'm listening.
It's how the model chooses which experts to activate.
How does it do that?
Well, there are 2 main ways: expert choice and token choice routing.
Okay.
So with expert choice, each expert picks a set number's tokens. Yeah, the bits of input, like words or phrases.
Got it.
It's like doctors signing up for shifts at the hospital.
Okay.
But what if a patient comes in with something really rare and that expert isn't on shift?
Oh, I see the problem.
Right. That's where token choice comes in.
So with token choice routing, it's about finding the best expert for that specific piece of information.
You got it. Like referring a patient directly to the right specialist?
That's much smarter. So the data guides the process.
Exactly. They actually found that token choice routing performed better.
Interesting.
But they needed a clever trick to keep things running smoothly.
What trick?
It's called load balancing loss.
Load balancing loss. Sounds complicated.
It's actually pretty simple.
Okay.
Imagine you have this super efficient system.
Yeah.
Everything goes to the perfect expert, but without any control, some experts get swamped while others do nothing.
Like an uneven workload.
Exactly. So load balancing loss acts like a traffic cop.
It keeps things balanced.
Exactly. Make sure all the experts are used.
Makes sense. But didn't you say researchers are rethinking this constraint?
Yeah, it's fascinating. While it's needed now,
Right.
removing it could lead to even more specialized experts.
Wow, how so?
Instead of everyone working equally, some could become hyper-specialized.
Even if they're only needed occasionally.
Precisely. It's like saying, this doctor is the best at this rare thing, so they'll be on call for that.
But they might spend most of their time just staying up to date.
Exactly. It raises big questions about the future of these models.
Would we see AI with even more focused skills?
It's a possibility. And it all ties into how OLMoE behaves in action, how it uses its experts.
Okay, let's get into that. I'm curious to see how this model thinks, its personality.
All right, let's see what we can uncover.
Sounds good.
One of the things we've seen is this thing called router saturation.
Router saturation.
Yeah, it's like the model figures out which expert to use for certain data early on.
So they're kind of picking their specialties.
Exactly, like how we start broad and then focus on what we're good at.
I see. So OLMoE's router's like, okay, you're the expert for this, stick with it.
Right, it makes the learning process super efficient.
Makes sense. So are these AI experts, like, always working together?
Actually, no.
No.
The research shows they rarely co-activate. They mostly work solo.
Huh. So each one has its own unique knowledge.
Exactly. Minimal overlap, very specialized.
Like a team where everyone knows their role, no need for constant meetings.
Exactly. And when you look closer, you see clear domain specialization.
Like some experts are better at certain tasks.
Yeah, just like human specialists.
Give me an example.
Well, some excel at processing scientific papers, others are coding whizzes.
Wow. So they're really developing their own interests.
It's like they're drawn to specific types of data.
So OLMoE isn't just efficient, it's becoming specialized, almost human.
That's what makes it so interesting.
It really does.
Yeah.
And it goes even deeper.
Oh,
It
yeah.
has specialized in vocabulary, too.
We call it vocabulary specialization.
What does that even mean?
Imagine an expert that's amazing with math symbols. Another one loves literary terms.
So one's like a Shakespeare expert, the other's fluent in physics.
Exactly. They each have their own linguistic niche.
That's wild. So efficient learning, domain 80 vocabulary specialization, OLMoE is really something.
It's definitely pushing the boundaries.
It is.
Yeah.
So where does this all lead? What's the bigger picture?
Well, OLMoE is a huge step forward, not just for MoE, but for open source AI as a whole.
So it's showing that you can have both, high performance and efficiency.
You got it.
You mentioned earlier, no other MoE model has been trained this much.
Right.
Why is that so important?
It lets us study how these models do over long periods of training.
I too.
We can see how their performance compares to traditional models.
So it's paving the way for more research, helping us understand MoE better.
Exactly. It's a valuable tool answering big questions about the future of language models.
Well, will MoE be the standard? What's the best setup for different tasks?
Those are the kinds of things we're trying to figure out.
It feels like we're just scratching the surface with OLMoE.
Absolutely. There's so much more to discover.
And it shows what open source can do, this incredible pace of innovation.
For sure.
But what does this all mean for, the average person? How will these advancements affect us?
Well, if these experts are already specializing like humans,
Right.
could future models have even more distinct personalities, more capabilities?
A more diverse and powerful AI landscape, where they're like partners, collaborators.
It's exciting, but maybe a little scary too, right?
Totally. It feels like a huge shift in how we think about and interact with AI.
And OLMoE is right there at the forefront.
Really in the way.
The fact that it's open source means anyone can get involved, experiment, contribute.
That's the beauty of it. Everyone can help shape the future of AI.
Exactly. So, to our listener, if you're curious, check out the links we've provided.
Dive into the research, see the code, maybe even try using OLMoE yourself.
You never know what you might find.
It's all about exploring and pushing the boundaries of what's possible.
Absolutely.
This has been an incredible deep dive into OLMoE.
It has.
Thank you for joining us on this journey into the future of AI.
My pleasure. Yeah, it's really something special.
It makes you think, where could this all go? Could these specializations, with the experts, get even stronger in the future?
That's the million-dollar question. And researchers are digging into that right now.
I bet they are. It's such a fascinating idea.
One thing that really stood out in the OLMoE research is something called router saturation.
Router saturation. Okay, you lost me there. What's that all about?
It means the model learns to send certain types of input to the same expert early on in training.
Oh, interesting. So it's like each expert is claiming their territory.
Exactly. They're saying, this is my area of expertise. I'm the go-to guy for this.
I love that. It's almost like they're developing their own personalities, these AI experts.
And the fact that it happened so early on tells us it's not just random, it's how these MoE models learn.
Makes sense. So could this lead to even more specialized AI in the future? Systems that are hyper-focused on just one thing.
Absolutely. Imagine having AI assistants that are truly masters of their craft.
Like, instead of a general helper, you'd have one for law, one for finance, one for writing.
You got it. A whole workforce of AI specialists.
That's incredible. But wouldn't that take, a ton of data and power to train them all?
It's true. Training these models is resource intensive.
Right.
But remember, OLMoE has shown us we can be efficient and powerful.
True. True.
And as the research progresses, we'll find even better ways to train these specialized models.
That's good to hear. It feels like every day there's something new happening in AI. It's exciting and a little bit scary, you know?
I know, you're...
But let's not get ahead of ourselves. OLMoE is already a game changer,
Absolutely. It's pushing the limits of open source AI.
showing that you don't need those massive closed-off models to achieve amazing results.
Exactly. It's all about open collaboration and transparency.
And that's what makes it so exciting.
If you're listening and you're as intrigued by OLMoE as we are, go check out the links we have in the show notes.
Dive into the research, look at the code, even try using OLMoE yourself.
It's a great way to learn and maybe even contribute to the field.
You never know what you might discover.
That's the spirit. Always keep exploring and pushing the boundaries.
Well, this has been an amazing deep dive into OLMoE, a real eye-opener.
It has been fascinating.
Thank you so much for joining us and sharing your expertise.
My pleasure. Always happy to talk about this stuff.
And to everyone listening, thank you for joining us on the deep dive. Keep that curiosity burning, and we'll see you next time.